everybody. I thought I'd go through some of the problems in your book today for extra practice for you, and then you can go through some of them. I'll give you some of them for you to practice. And let's take a look at 18.5. Let me put the number here, 18.5. And what this is, they talk about selecting an acre of land in Canada at random, and the probability is 0.45 that it is forest and 0.03 that it is pasture. Okay, what is the probability that the acre chosen is not forested? Okay, so not forest. That is simply the complement of forest. So it's 1 minus 0.45, and that's just 0.55. Nothing too creative there. What is the probability that it is either forest or pasture? So that's those two are distinct items. If it's forest, it can't be pasture. So we will, let's put this in here. So you're going to have 0.45 plus 0.03. That's just going to be 0.48. And then part C. What is the probability that a randomly chosen acre in Canada is something other than a forest or pasture? So that just means it's neither forest nor pasture. We know what forest or pasture is, so it's just going to be 1 minus that. It's the complement. So it's 4.52. Okay, pretty good, huh? I think it's pretty good. I hope you think it's pretty good. All right, that's a good one. And let's see. Let's take a look at problem 18.19. So we're going to talk about jogging. Yuck. For those of you that are runners, sorry. I'm a cyclist, not a runner. So what they want to do is seeing that the population proportion is about 0.15. And so that follows a normal distribution with a mean of 0.15 and a standard deviation of 0.009. Okay? And we're going to sketch the normal curve. No, we're not. And we're going to use that to to answer the following questions. What percentage of many samples will have a sample proportion to jog that is 0.15 or less? Okay? So if the mean is 0.15, and they're saying what is the probability? This is another problem. If that's 0.15 or less, okay, remember we're talking about a normal now. So what do we know about then it has to be, of course, 0.5, right? Good. Real good. Okay. Alrighty. Then, what is the probability that p hat will take on a value between 0.141 and 0.159? Use the 68, 95, 99.7 rule. Well, I would say to myself, isn't it true that 0.15 plus 0.009 is 0.159? Isn't that the upper bound of that? It is. Therefore, this is the mean, the p hat, plus one standard deviation. Therefore, this is in that 68th percentile. So I'm looking at 68%. Does that make sense? Okay, good. Great. 68% because we're within one standard deviation of the proportion. The same thing that happens with a mean happens with the proportions. It's the same kind of thing. Okay? And part C. What is the probability that p hat does not lie between 141 and 159? Okay, it's the complement. So if 68 is within, then 1 minus 0.68 must be it. So it has to be 0.32. Okay? Isn't that nice? Good. All right. Problem 18.21 is very, very interesting, I think. And we're going to do a little bit of simulation studies. So in here you have, they labeled students 0 through 9. There's 10 students. And they have scores, various scores. Because you want to do a single digit. That's why it's not 1 through 10, it's 0 through 9. Okay, so the first thing we're going to do is get the mean based on the scores. So let's put in their scores first of all. Let's call it SC for scores. You know what, I'm going to use Slacker and use Scan. I like Scan better. Okay. And we have 82. And then 62. And 80. And 58. Oops. 58. And 72. And 73. 65. 66. And 74. And 62. All right. So there's our 10 scores. We want to get the mean first of all of SC and 69.4. All right. And what we want to do is draw a simple random sample of size 4 from this group. So what we want to do, I'll show you something kind of cool. I want to sample 0 through 9, replace equals false, and I want to do 4 of them. Okay, so let's see who we have. 4, 1, 8, and 2. Now remember, this is 1 up. Okay, so SC, we need an X, what should we call this? XSP goes from 9. And so we need to get SC such that SP equals XS. I think that's it. Nope. How about this? I should have 4. I only have 3. Okay. I know what I'll do. SC is XS plus. Okay. Right, so it's 4182 plus 1. Okay. And let's get the mean of that. Okay, so my mean's a little bit higher. Now, I'm going to repeat this 10 times. What I'm going to do is set up a little matrix. Not very creative, but it'll get the job done. Okay. And let's see. What's the best way to do this? For, let's see, X mean is numeric. Don't worry, I wouldn't expect you to do this without all the steps written out. Length equals 10, because I want 10 of them. And I want for I in 1 through 10. My fault. I want to do XS, so I want to do my sample. Actually, let's just do sample 1 through 10. Replace equals false. False. And I want a size 4. Okay. And I want, let's see, X mean for that step is mean of SC of XS. Okay, and let's look at X mean. There. And they want us to do the histogram. Let's look. Okay, so it's actually a little low because our original value was 69.4, so it's running a little. In this one, the frequency, the highest frequency, is between 68 and 68 and 69, and one of the lower ones is at between 69 and 70. That is very interesting. Okay, now just humor me for a moment. What if we did an X mean that was 1,000? I know you're going to love this, don't worry. For I in 1 through 1,000. Still that. And I still have the same X mean. Okay, now I do a histogram of X mean. Now let's take a look and see what it looks like. Yeah, there we go. That's as it should be. So here it's picking it up. So if you just do that little one like that, it's not going to show it. But here where you've got the larger sample size, it will. Okay? So when you have that large N like that, that's where you're going to pick up your value. Okay? Thanks for humoring me, and hope you learned something. Thanks.